Hi there. Continuing our work on functions, we're going to look at the modulus function and graphs to do with it and solving equations to do with modulus functions. So we've got the thrill, the joy of sketching graphs today. We all love sketching graphs, I know that. So first things first, what is the modulus function? It's where we write something like a number, a value, an expression between these two lines like this, and we basically ignore the minus sign of it and make it positive. Obviously, if there's a zero in there, we'd end up with zero. So let's have a look at how we would draw modulus, or what are called mod graphs. So if I want to draw y equals the modulus function of x minus 2, let's have a look how x minus 2 would look. It would look like a nice straight line like that, crossing the y-axis of minus 2 and hitting the x-axis at 2. What happens is, whatever y value I put in, whatever x value I put in, the y value, because it's mod of it, will always be positive. It can never be negative. So that part of the line stays as it is. This part down here, though, gets reflected in the x-axis and will go like that. So we'll cross the y-axis at 2. So the idea is, when x is 0, we put 0 in. We get mod of minus 2, which is 2. When x is 1 in, we get mod of minus 1, which is 1, and so on like that. So basically, for this sort of function, for these, y equals mod of a function of x, whatever would have gone below the x-axis gets reflected above. So let's have a look at the second example. Y equals mod of tan x. Tan's a rather funky little curve, isn't it, as we all know. It's got asymptotes at 90 and 270 and so on if it's in degrees. And we'll go like that, and will be repeated there, and so on there. What happens below this part here will get reflected there like that, and similarly on that part here. It should really have numbers in, so it should have 180, 360 and so on. There's 90, there's 270. It's not an x squared curve with a nice sort of flat bit at the bottom there, but we'll go through the x-axis at an angle, so we'll be more pointed. If I was to sort of zoom in, it's sort of doing that and that, and having a more pointed look at that point there. It's not a smooth curve as such. Let's have a look at an ordinary quadratic curve and the mod of it. So y equals mod of x squared minus 3x minus 40. First thing you need to know is how the curve looks where it crosses the x-axis. So let's solve this thing equal to 0, and to do so it's probably a good idea to factorise it. X minus 8, x plus 5 equals 0, x equals 8 minus 5. So we cross it at minus 5, it crosses at 8, it looks like this. Please, 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 we know this anyway, but just in case, do not assume that these quadratic curves will have a maximum or minimum on the y-axis. If we know where it crosses the x-axis there and there, it has to be halfway in between, which in this case, halfway between 8 and minus 5 is at 1.5, so it would sort of bottom out here. So the original curve would look like that, and bottoming out there, and going on to be there. So our mod version of it would look like this, and like this, there, and this part of it will end up topping out at x is 1.5, so it'll do that there. And to complete the information, it's going to cross at plus 40 when x is 0, mod of minus 40 is 40. So we have our quadratic curve, like that, symmetrical curve, but the bit that's below the x-axis gets reflected above the x-axis. Okay, let's have a couple more of these then. These ones are slightly different. Now, when we have combinations of transformations, so in this case we have a mod graph, and then we're going to do something else with it, it's best to do several sketches. And these are actually, historically with our students, they've done very well at these questions, as long as they follow these steps here. So I'm going to look at the mod of x plus 2 first, which would hit the y-axis at plus 2. It would go, therefore, like this. It would bounce off at minus 2 and cross at 2. So our or graph it would look like that. What does the minus 3 do to it then? It shoves everything down by 3. So it takes this thing, in this case this function will have things below the x-axis, but it will have nothing below y is equal to minus 3. So we're going to have, instead of crossing at 2, it's going to cross at minus 1, and it's going to go like that. There, should have done a bit more here, and like that. So it's going to bottom out at minus 2, minus 3, and it's going to cross there at minus 1. And if I had a bit more thinking about it, we could then solve where it would cross the x-axis. But at the moment, that will be an extra part of the question. This example 5 we've got is different. It's not mod of a function, it's f of mod of x. Now what that means is, whatever x value I stick in, if it's negative, the mod makes it positive, and the y will be exactly the same as what it was for the positive value. What I mean is this: if I look at a sine curve, if I did this part of the sine curve up here, like this, that didn't help, I'm nudging myself there. Try again. And so on like that. What happens for f of mod of the function? All this part of the curve gets reflected on the other side. So the idea is, when x equals minus 30, that's the same y value as when x is equal to 30. So this part over here will end up over here. So we do get bits below the x-axis in this case here. So we'll have that, there, and so on like that. So it would be a partial reflection. Whatever went on this side of the y-axis has disappeared. The difference between f of mod x and mod of the function is, all the original curve for mod of the function appears in the sketch. In this one, whatever appeared on this side has gone, disappeared. It's a partial reflection in the y-axis. Just to complete it, we're going to cross at 180, we're going to cross at 360, we're going to cross at minus 180, minus 360, and with it being sine, we know it tops at 1 and bottoms out at minus 1. So in this case, I don't think there's much to do with f of mod x in our course anymore, less than there used to be, but it's worth looking at that. And the last couple is to do with solving equations and solving inequalities. So example 6 says solve x minus mod of x minus 1 is equal to 4. Two ways of doing it. One is by solving two different equations, and the second one is by squaring. So the first one I'm going to solve is when I've got the function x minus 1 equals 4. And solve it to get x equals 4 plus 1, 5. What I can also do is, because it's mod of it, minus that function is equal to 4. What I tend to do rather than that though, I'll say the function I'm looking at can equal minus 4. And then x equals 1 minus 4 minus 3. So I've got my two solutions in this case here. If I squared everything, I'd have x minus 1 all squared equals 16. I could square root it, but I'm back to where I started. What they want me to do in this case is multiply it out. Plus 1 equals 16. And take the 16 across to get x squared minus 2x minus 15 equals 0. X minus 5. X plus 3 is nothing. And guess what? X equals 5 or minus 3. Just as I had before. Right. Last one though is solving an inequality range between two different mod functions. First thing I'm going to do is do a sketch of it. Now be aware when you're sketching a few things, particularly with these mod ones. Look at the gradients, because this is 1x plus 3, that's 3x there. That's going to be a shallower line than this. And particularly if the question involves lines and quadratic curves. Please remember that a line is shallower than a quadratic curve. I see lots and lots of people will do nice little curves like that and a line like that. Sorry folks, that's not going to happen. We're going to have much, much steeper curves than lines. So in this case, mod of x plus 3 crosses the y-axis at 3 and bounce off at minus 3. And I'll try and do a nice shallow looking line there. So that's at 3 and minus 3 and that's at 3. 3x minus 5 would want to cross down here at minus 5. It will be steeper. It will hit the x-axis at 5 over 3, like that, and bounce off somewhere up there, and cross there at 5. So that's roughly how the thing looks. I'm after, therefore, well, the first thing I need is where the things cross over, and from then I'm going to use my sketch to solve the inequality. So I'm going to solve mod of x plus 3 is equal to mod of 3x minus 5. How to do it? Do it without the mods first, like this, and solve it to get 3 plus 5, 8 equals 2x, x equals 4, with that one there. And then solve, you can make either one of these negative. If you make both the functions negative, you get exactly the same as what you had in the first bit here. So if I made it minus x plus 3 equals 3x minus 5 and solve that, and then we're off and running. So 5 minus 3 is 2, and x plus 3x is 4x, x equals a half. So that's an x is a half there. And what I want is where the shallower line is above the steeper one, and that is just in this bit here. Every other x value, that's steeper there, and so on. So it's just the sandwich range between my two solutions. So x will lie between a half and the other solution, x equals 4. So sketches are key. Make sure you're looking at which ones are shallower and steeper, and if you have a curve and a line, make sure your curves are steeper than your lines.